Hi and welcome back. So in this video, we are going to look at subtopic 14.2 thermodynamic processes. Okay, there are two learning objectives in this subtopic. The first one is to define the thermodynamic processes. We have 4 thermodynamic processes and we are going to define all these 4 processes. And the next one is to discuss the pressure versus volume graph for all the thermodynamic processes. Okay, so first we are going to look at the type of processes we have for thermodynamic. The first type we have is isothermal process. And the second one is isovolumetric process. And then next we have isobaric process. And finally we have adiabatic process. So we have 4 types of thermodynamic process. So now we are going to look at the definition of those processes. We're going to start with isothermal. What is isothermal process? Isothermal is a process that occurs at constant temperature. Alright, so isothermal is a process that occur at constant temperature. Maksudnya, dalam sesuatu thermodynamic process yang melibatkan isothermal process, dia memberitahu atau dia membawa maksud that in that particular process, the temperature did not change. The temperature at the initial process is equals at the end of the process. So by the end of the process itu, temperature dia tetap sama. Kita tidak mengubah temperature. The temperature is kept constant here. So our T is constant. Bila T constant, in chapter 13 kita ada belajar internal energy U. If you remember, U adalah F/2 nRT. Remember? Okay, F degree of freedom bergantung kepada type of the atomic. N dan R adalah constant. Number of mole dan juga molar constant dekat sini. So all these are constant here. So we can deduce that your internal energy is directly proportional to the temperature. So bila kita ada proses initial dan juga final, okay, initial dan juga final, kita akan ada internal energy at the initial of the process dan juga internal energy at the final of the process. Therefore, kita boleh cari change in the internal energy such that final minus initial. Okay, when the temperature is kept constant for isothermal process, maksudnya your initial internal energy akan sama dengan final internal energy because U is directly proportional to the temperature. So bila temperature tidak berubah, whatever internal energy you had initially akan sama dengan internal energy pada hujung proses. So the internal energy here is the same. So bila dia sama, apa yang akan jadi adalah your internal energy becomes 0. So the key term dekat sini adalah setiap kali dia cakap isothermal process, kita kena tahu bukan saja T constant, U juga constant. Disebabkan U constant, the change in the internal energy, delta U kita menjadi kosong. Automatically it becomes 0. Since the change in the internal energy becomes 0, according to the first law of thermodynamic, kita cakap delta U is equals to Q minus W. This was the first law. Disebabkan delta U kita kosong, what happened here is the heat is equals to the work done. Okay, the heat is equals to work done. Okay, so the key yang kita kena ingat, isothermal, temperature constant, delta U 0. Okay, ini yang awak kena ingat. You have to make sure whenever you look at the term isothermal, temperature constant, delta U 0. Okay? Alright. So kita akan terus tengok pada bentuk graf untuk isothermal process. Untuk isothermal process, the temperature is kept constant. So if you were to sketch a graph of P versus V, kita ada initial situation, initial process dan juga final process. Kita akan ada initial dan juga final process. Waktu initial kamu akan ada satu pressure P, kita panggil dia initial pressure, dan kita akan ada volume tertentu pada permulaan proses tersebut which we call as initial volume. Begitu juga after a certain process has been done where you kept the temperature constant, bila temperature is kept constant, faktor-faktor lain kena berubah. So your pressure is going to change to a new value will have, let's say kita panggil final pressure, begitu juga volume akan berubah, memberi kita final volume. So both the pressure and the volume akan berubah. Let's say ini saya panggil sebagai initial pressure saya dan ini final pressure saya. And then this as my initial volume and this as my final volume. What is going to happen adalah at the starting of the process, kita tukar, selalunya dia terbalik bila volume kecil, pressure akan besar. They are inversely proportional. Okay, they are inversely proportional. Let's say my initial pressure is greater. Initial pressure greater at a initial volume. So saya berada pada titik sini. And then after the process, after the isothermal process, my pressure and my volume changes to final. So what is going to happen adalah, this is the shape of my isothermal process, di mana this shape indicate that the temperature is kept constant. Temperature dekat titik A sama dengan temperature at titik B, because along this curve they have the same temperature. Pressure mereka berbeza, volume mereka pun berbeza pada kedua-dua titik A dan juga B, because temperature is kept constant. Let's say kita ada another process. Katakan proses kedua pula. Okay, proses kedua ni, proses seterusnya adalah dia bergerak dari sini contoh at different temperature. Katakan ini temperature 20 Kelvin. Kita ada another temperature katakan 15 Kelvin. So this is the shape. Dia punya shape sentiasa bentuk dia yang curve melengkung ini. Cuma along that particular curve, the temperature is the same. Ini 20. Along this second curve kita, temperature dia let's say 15. Alright, this is isothermal. Next, we are going to look at isovolumetric. Untuk isovolumetric, by definition, it is a process where the volume is kept constant. Maksudnya proses ini hanya akan berlaku bila volume dia constant. So bila dia cakap isovolumetric, maksudnya volume is kept constant. Okay, bila volume is kept constant, for constant volume, okay, work done dia akan sama dengan kosong. Okay, kenapa work dia akan sama dengan kosong dekat sini adalah kita akan terus tengok bila kita sketch graph ini. Okay, kenapa work dia akan kosong? Kita akan tengok bila kita, bila kita belajar subtopic 14.3. Bila kita tengok subtopic 14.3, I will explain why do you get the work done is equals to 0 for constant volume. Okay, at this particular point, kita nak tengok dulu, kita nak fahamkan kata bila it is an isovolumetric process, the volume is constant, V dia constant, dan bila V constant, apa yang dia cuba sampaikan adalah work done kita kena kosong. So according to the first law of thermodynamic, delta U is equals to Q minus W. Since it is an isovolumetric process, W is equals to 0. Q kita akan sama dengan change in the internal energy. So whatever heat that is added to the system is equals to the change in the internal energy. So ini antara benda yang kamu kena tahulah kan. Bila isothermal, delta U kosong. Bila isovolumetric, work done kosong. Okay, ini adalah hidden information yang memang kita kena tahu sebab dia selari dengan proses-proses tersebut. Okay, now we are going to look at the graph sketching here. Okay, so since the volume is kept constant, maksudnya at the initial of the process, let's say you have volume kamu sebanyak V initial, this is the initial state, and then you're going to have pressure, which is initial pressure juga, let's say. Okay, pada permulaan proses itu, you're going to have initial pressure, initial volume. Let's say this is your initial pressure and initial volume. Kita berada dekat titik A di sini. Alright. And then by the end of the process, whatever changes that happens there occurs across the temperature and also the pressure without changing the volume, sebab kita kept the volume constant. So bila volume tidak berubah, volume initial kita adalah V initial, kita letak dia sebagai V initial. Pada permulaan proses dia adalah V initial, maka pada akhir proses pun dia punya nilai sama dengan V initial kamu. Dia sama dengan nilai V initial. Maksudnya V kita tidak berubah. It's just that the pressure changes to final pressure now. Okay, dia pergi duduk dekat sini. Okay, so without changing the volume, your pressure and also your temperature changes. Okay, pressure dan juga temperature dua-dua berubah. Okay, so this is what we call as isovolumetric graph of P versus V where the volume tidak berubah. Okay, volume dia tetap sama pada titik A dan juga titik B kita. Next, we are going to look at the isobaric process. For the isobaric process, it is a process that occurs at constant pressure. Okay, isobaric adalah constant pressure. Maksudnya pressure dia tidak akan berubah. So whatever changes you are going to do in the initial state of a process dan juga final state of the process, you kept the pressure constant. Kita kekalkan pressure dia. Kita tidak mengubah pressure. Okay, when you did not change the pressure, it did not affect any of the term in the first law of thermodynamic. Okay, dia tidak mengeffect delta U because your internal energy is not related to your pressure directly. Begitu juga dengan heat kamu, begitu juga dengan work done kamu. So for an isobaric process, it is not going to affect that much of your first law of thermodynamic. Okay, dia tidak sama macam isothermal. Bila saya cakap isothermal, kita tahu delta U 0. Okay, berdasarkan explanation yang Miss bagi tadi, isovolumetric work done dia akan kosong. Kita akan tengok pada video 14.3 nanti. And then for isobaric process, the P is constant. Itu saja informasi yang kita tahu. Isobaric, P constant. Dia tidak mengefek apa-apa term dalam first law of thermodynamic. Okay, so maksudnya pada permulaan sesuatu proses, let's say at the stage 1 of the process, initial case kamu ada pressure 1 dekat sini, and then you have volume, let's say volume 1. Okay, and then at the second stage of the process, kita berubah, okay, kita ubah temperature, kita ubah volume, tapi kita tidak mengubah pressure, you kept the pressure constant. So the pressure at stage 2 sama dengan pressure at 1, pressure kita tidak berubah. Tetapi volume kita akan berubah ke nilai yang baru. So what is going to happen? Let's say at the stage 1 here, you were at P1 and also V1. Okay, and then at the stage 2, what happen is your pressure is kept constant, tidak berubah, cuma volume kamu berubah, maka volume berubah pergi ke volume yang seterusnya, V2. Okay, so this is the shape of the graph for your isobaric process where the pressure is kept constant. Okay, pressure dia tidak berubah. Nilai P dia tetap sama sepanjang proses. Whereas for adiabatic process, untuk adiabatic process, it is a process that occur without heat transfer. Maksudnya, kita tidak akan menyebabkan perubahan dari segi heat dekat sini. Okay, you are not going to transfer masuk heat ataupun transfer keluar heat. You're not going to insert any heat into the system, or you're not going to release any heat in the system. Maksudnya there is no heat being transferred. Tak ada heat langsung. Okay, bila tak ada heat being transferred, Q kita sama dengan kosong because Q is the heat energy. When there is no transfer of heat, the value of Q here automatically becomes 0. So according to the first law of thermodynamic, delta U is equals to Q minus W. Since your Q is equals to 0, your delta U automatically equals to negative W. Alright? Okay, next we're going to look at the graph of P versus V for adiabatic process. So for adiabatic process, apa yang jadi adalah you just did not allow any heat transfer. Kita tidak menggalakkan sebarang heat transfer to occur. However, dalam stage pertama proses tersebut, at the initial stage, you have a pressure, you have a volume called P1, V1, and then you make sure there is no heat being released ataupun masuk ke dalam proses itu. So, untuk fokus pada proses tersebut, to focus so that there is no heat being transferred, you allow the pressure to change to a new value and also the volume to change to a new value and also the temperature changes. Kita akan ada T1 dan juga T2 juga. Temperature akan berubah. However, since kita tengah fokus pada graph P versus V saja, we don't really talk much about the temperature lah kan in terms of value. However, the temperature also changes. Okay, contoh kamu berada pada nilai P1 dan juga V1 V2 contoh sekarang. Okay, V1. Ini adalah nilai V1 kamu. So, you are at this particular point here. Okay, this is your P1 and V1. Okay, and then as the process adiabatic expansion berlaku, bila adiabatic expansion berlaku, what is going to happen adalah, sebab kita tengah cakap pasal expansion, the volume is going to increase, pressure is going to decrease, sebab pressure dengan volume are inversely proportional according to chapter 13. So kita punya pressure baru decrease, volume baru kita meningkat. So you're going to have a new value dekat sini, akan berada dekat titik sini. So what is going to happen here is your process here move from this particular point to this particular point. Awak berada pada curve yang begini. Curve ini, kalau kamu tengok dotted line yang Miss ada lukis dekat sini, this dotted line here, this first dotted line represent a temperature, let's say temperature 1. This second dotted line is another temperature 2. So as you have a different curve dekat sini, you're going to have different temperature. Tapi apa berlaku adalah kamu punya initial state dengan final state melibatkan dua curve yang berbeza. Dia melibatkan dua curve yang berbeza, maka dia melibatkan dua temperature yang berbeza juga dekat sini. So everything changes except for you did not allow the heat to transfer. This is all about your 14.2. Okay, so the first learning objective adalah kena faham apa definition of each of these process. Maksud isothermal, process that occur at constant temperature. Isovolumetric, process that occur at constant volume. Isobaric, process that occur at constant pressure. Adiabatic, process that occur without heat transfer. Kena faham definition dia. Next adalah kena faham macam mana nak lukis dia dan apa informasi yang dia cuba sampaikan bila dia guna term-term untuk setiap proses ini. Okay, so you must know how to sketch all this graph for respective